So today we have a nice trigonometric question. It has been given that if cos 35 degree has a value that is equals to a, then find the value of sine of 80 degree upon 2 times cos of 20 degree plus 1 in terms of a. So let us see the solution. How can we solve for this? So first of all, we are going to simplify this particular thing, and in this also concentrate on the numerator, that is sine of 80 degree. So what we are going to do is expand this using a trigonometric identity. The identity is that sine of 2 times theta, that is sine 2 theta, and this thing is going to be equals to 2 times sine of theta into cos of theta. This is a trigonometric identity. Now in this particular identity, if I will replace theta as equals to 40 degree, in the left hand side we will have sine of 2 times 40, that is sine of 80 degree, and this thing would be equals to 2 times sine of 40 degree multiplied with cos of 40 degree. So here what we have is sine of 80 degree but in an expanded form, that is 2 times sine of 40 into cos of 40. So here we have just expanded sine of 80 degree as 2 times sine of 40 degree into cos of 40 degree. Now again in this, look carefully to sine of 40 degree. We can again expand it using the same identity, that is this one sine of 2 theta is equals to 2 times sine theta cos theta. In this, if I will replace theta is equals to 20 degree, in the left hand side we will have sine of 20 degree, that would be equals to sine of 40 degree, and this thing would be equals to 2 times sine of 20 degree into cos of 20 degree. So here we have expanded sine of 40 degree. So we'll put this value of sine of 40 degree over there. So finally we will have the value of sine of 80 degree, that would be equals to 2 times sine of 20 degree multiplied with cos of 20 degree to cos of 40 degree. So here we have finally expanded sine of 80 degree. So now let us replace this thing in the original equation. So in this original equation, let us rewrite sine of 80 degree as this particular thing, that is going to be equals to 2 times sine of 20 degree multiplied with cos of 20 degree multiplied with cos of 40 degree, and in the denominator 2 times cos of 20 degree plus 1 as it is. Now in this numerator, all these terms are in multiplication, so we can just adjust the terms, like a into b into c can also be written as b into c into a, or else a into c into b. This means in multiplication the terms can be just adjusted. So in this also I will just adjust the terms. So these terms that are in multiplication, I will keep them in two brackets. The first bracket will contain 2 times sine of 20 degree. Let me show you the factor in this also. 2 times sine of 20 degree, and in the second bracket we will keep 2 times cos of 20 degree multiplied with cos of 40 degree, and now in the denominator 2 times cos of 20 degree plus 1 as it is. You can see that all these terms that were in multiplication, I have just separated them with brackets, 2 times sine of 20 degree together and 2 times cos 20 cos 40 in another bracket. So now we have this particular equation, and in this we are going to apply a trigonometric identity so as to change this thing into something else. The identity says that cos of theta plus cos of alpha is going to be equals to 2 times cos of the complete angle as theta plus alpha upon 2 multiplied with cos of theta minus alpha upon 2. So this is the identity of cos of theta plus cos of alpha. So now in this particular identity, if I will replace theta plus alpha upon 2 as equals to 40 degree and theta minus alpha upon 2 as equals to 20 degree. So here we have two equations that are containing two variables, that is theta and alpha, so they are very easy to be solved. And when we will solve them, we will get that theta is equals to 60 degree and alpha is equals to 20 degree. So we have this particular identity that cos of theta plus cos of alpha is equals to this thing. In this we have just let theta plus alpha upon 2 be equals to 40 and theta minus alpha upon 2 be equals to 20 degree. So now what we are going to do is put all this value again in the same equation. So now the right hand side of this equation will look like this way, 2 times cos of 40 degree multiplied with cos of 20 degree, as this thing was considered as 40 and this thing was considered as 20. And the left hand side, that is cos of theta plus cos of alpha, as we have the value of theta and alpha, so it will look like this way, cos of 60 degree plus cos of 20 degree. So here we have got the value of 2 times cos 40 multiplied with cos 20, that is cos 60 plus cos 20. So here is the last step where we stopped. Then we applied this trigonometric identity and got this particular thing. Now the right hand side of this equation is 2 times cos 40 multiplied with cos 20. And now look carefully in this thing. This complete bracket is 2 times cos of 20 into cos of 40. And we have the same thing over here. This means that cos of 60 degree plus cos of 20 degree is equals to this thing. So over there, this bracket can be replaced with the left hand side of this equation. So let us do that. So now we will have 2 times sine of 20 degree as it is multiplied with cos of 60 degree plus cos of 20 degree, and in the denominator 2 times cos of 20 degree plus 1 as it is. Now remember that cos of 60 degree has a value that is equals to 1 upon 2. So let us replace it over here. So 2 times sine of 20 degree as it is multiplied with 1 upon 2 plus cos of 20 degree, we can take LCM over here. So 1 upon 2 plus cos of 20 degree, after LCM will become 1 plus 2 times cos of 20 degree. The denominator of this particular thing is 2, and the denominator of this whole thing was equals to 2 times cos of 20 degree plus 1. Now this 2 and this 2 can be cancelled out. So now what we have is sine of 20 degree multiplied with 1 plus 2 times cos of 20 degree, and in the denominator we have 1 plus 2 times cos of 20 degree. So as this complete thing is in multiplication, so we can cancel out this and this. So after all this cancellation, the final thing that we have is sine of 20 degree, and this thing was equals to sine of 80 degree upon 2 times cos of 20 degree plus 1. This was the original thing that we were simplifying, so we got finally a sine of 20 degree. But what we were trying to solve is this in terms of a, and a was considered as cos of 35. It was given that cos 35 has a value that is equals to a. So firstly, our main motive was to get this thing in a very simpler form. So here it is, that is sine of 20 degree. Now we need to convert sine of 20 degree into cos, because cos 35 has a value equals to a. So because of the complementary rule that cos of 90 minus theta, that is cos of 90 minus theta, is equals to sine theta. So in this, if I will replace theta as equals to 20 degree, we will get that cos of 70 degree has a value sine of 20 degree. So sine of 20 degree can be replaced as sine of 20 degree can be replaced as cos of 70 degree. But again, we have the value of cos of 35, not cos of 70. So here we are going to apply a trigonometric identity. The identity says that cos of 2 times alpha is going to be equals to 2 times cos square alpha minus 1. Now in this particular thing, if I will replace alpha as equals to 35 degree, so now in this equation, if we will replace alpha as equals to 35 degree, so in the left hand side we will have cos of 2 times 35, that is cos of 70 degree, and this thing would be equals to 2 times cos square alpha, so 2 times cos square 35 minus 1. Now as per the given data, cos 35 has a value equals to a, so cos 70 is equals to 2 times cos square 35 minus 1 will turn out to be 2 times a square minus 1, and 2 times a square minus 1 is the value of cos of 70. Cos of 70 is equals to sine of 20, and sine of 20 is equals to sine of 80 upon 2 times cos 20 plus 1. So here we have finally found the value of sine of 80 upon 2 times cos of 20 plus 1 in terms of a, that is going to be 2 times a square minus 1, and that's the answer that we were looking for. So this was my way to solve this particular question. If you have any other method other than this, you can do comment below, and if it's hard to comment, you can send it to me on my email, or else you can send it to me on my Instagram or Discord. The links are in the description.